Hello students, today we are studying the next topic of the chapter work energy, which is very important, and this will be carry of the 5 marks in the examination. We are doing total mechanical energy of the freely falling object remain conserved. Now already we have done that mechanical energy is the sum of the potential and the kinetic energy. Now if you see here, an object is there, okay, and this object initially is at the rest, and we are throwing this object from A point and it is reaching to the C point. So the total height it is attaining from the A to C, it is h, and at the point B it is, suppose it is traveling x, so this remaining distance will be called as the h minus x. If this total it is h and this is x, this would be h minus x. So at the each point A, B and C we will calculate mechanical energy. A, B, C point we will be calculating mechanical energy, and we know that mechanical energy is the combination of the kinetic and the potential. So first we are considering at the point A. At the point A we are supposed to calculate kinetic energy and potential energy. Potential energy is mgh. Kinetic energy we know the formula half mv square. Since the object is under the rest position, it is not moving, the velocity will be considered as the 0. Okay, so kinetic energy you will got here is 0, and mechanical we want to calculate is the combination, so mgh plus 0 you will get the mgh. Okay, second, at the point B, now you see that if when it is at the point B, if object suppose is reached here, and from here to here if we want to it want to move, it will move the distance h minus x. So at this point if we want to calculate potential energy is equivalent to m into g into h. Now m into g, and in the bracket when you put the value of the h, it is h minus x. So when you multiply mg with h, you will get mgh, and mgx you will get mgx. Okay, now for the kinetic energy we use the formula half mv square. Now here we will substitute this value of the v square by the third equation. Now if you see the third equation, v square minus u square equal to 2g. Okay, till here the distance moved it is x, so we are writing as x. Now initially the object, okay, so we can write here initially the object was in the rest position, so initial velocity is considered as 0. So if you put the values here, this term will be considered as 0. So v square you will get 2gx. Okay, then half m, in the place of v square you substitute the value 2gx, so we are writing here 2gx. Okay, so this 2 and 2 will get cancel and you will get the mgx. Okay, now again for the point B we are calculating the mechanical energy. So mechanical energy, again it is the combination of the kinetic energy and potential energy. Kinetic energy we have got here mgx, and potential energy we have got here mgh minus mgx. So when you substitute the values, in the place of kinetic energy you will write mgx, and in the place of potential energy we will write mgh minus mgx here. So this and this will get cancelled, and finally you will get mgx. Okay, now third, at the point C before touching the ground. Now why we have written this before touching the ground? If you see the object, when it is suppose reaching the ground, on reaching the ground again its kinetic energy will be 0 and potential energy will be there, so this case will become point A. Point A case will become, so we are calculating here before touching the ground. Now before touching the ground, if the object is at here, you can see that the height will be considered as h. Okay, so at the point C before touching the ground, since the potential energy, the object is under kinetic energy, no potential energy there, so it is 0. Kinetic energy it is half m v square. Okay, so half m, again in the v square v square minus u square 2gh, we are substituting the values of the v square. This term it is 0, initially the object was in the rest, so 2gh. Okay, and in the place of v square we are substituting the value 2g, is 2 and 2 will get cancelled and will get mgh. So we have seen here that at the each point A, B and C, the last we are getting as mgh. Here also we got mgh. Okay, here also we'll got, here it is the mgh, and Finally, here also we are getting the mgh. So what this proves, we are getting each point mgh. This proves that total mechanical energy at the each point A, B and C, it remain conserved.